welcome you all for the 82nd edition of Geek Night. So, before we get started, sorry, I got muted. Okay, so before we get started, we'll be having our next 2 hours filled with 2 hours. Oh, I'm sorry for the interruption. Okay. So let's get started. So for the next 2 hours, we'll be having our two talks. So to begin with, let's start with mono to micro frontends, which is going to be presented by Madhava Ippili from Verizon. So Madhava Ippili is an enthusiastic full stack developer who is currently working on Angular projects. And he's very much interested in exploring new tech stacks. And also, he's currently learning about Kubernetes. So we would really like you to present Madhava Ippili about mono to micro frontends. Over to you. And before we get started, folks, if you have any questions, please feel free to raise your hand, or you can even ask questions in the QA box. So we would really appreciate if this is an interactive session. Thank you. Over to you, Madhav.
Uh, Thank you, Monica. Hey, hi all. This is Madhav. I'm a full stack developer, and much of me was already well explained by Monica. Thank you for that, Monica. And let's begin the session without wasting any time.
Like you can share your screen, Madhav.
Yeah, I'm doing it.
Cool.
Yeah. Uh, Guess let me know if you all could see my screen.
Yeah, you're able to see your screen. Well and
Okay,
good.
thank you. Yeah. Okay. So something my title resembles some kind of chemistry and some kind of physics in that, and finally ending with the latest stack front ends. Okay. Okay, let me tell the background of the title. Let's have a 1 minute of talk about the title. Even I was also a basic web developer who is enthusiastic in knowing and learning about the new tech stack. So in that route, I worked on Angular JS and working on Angular React Vue, and also a full stack developer with mean, and complete Java development. So in these courses of time, even I worked on preparing the microservices for a couple of my applications. So in that time, uh, while I was working on Angular, which would really encourages us to prepare good web components or good web elements, which would be a completely independent of the whole code, and we can very well plug in them from one project to another project. This kind of flexibility we have from Angular. So in that course, I was just thinking like what other thing that I can do with Angular or React or Vue. So in that time when I was searching for the latest tech stack to include in my tech stack, so at that time I came to know about the new paradigm of architecture of the websites such as called micro frontends. So there the journey of the micro frontends from my side was started, and that's where I, I was curiously thinking what is this micro frontends, what actually it does, and does it really have any symbolic relation with the microservices. So that's how my journey started, and then I came to know that yes, it is the extension, or it is the a paradigm that they have followed from the microservices and they applied it to the front ends, and that's how they call it as micro front ends. And that reason of the title mono to micro front ends is uh, the reason to bring or to add micro to the front ends is we have only one paradigm till now of constructing the websites is the monolithic way, like getting all the services, preparing uh, the code that actually works for the service and linking it with the templates and deploying it. So this is the monolithic way. So I thought like this title mono to micro frontends would add a little curiosity, and we can kickstart today in a better way. Yes. So this is the agenda that I plan to deliver it today. So what is the definition of these micro frontends, and what issues or concerns are made to move from this monolithic way or the legacy paradigm to the latest micro front-end architecture, and what is the differences between this mono to micro front-ends, and what would be the benefits that if we are planning to shift our existing paradigm of implementing a website to micro front-end component architecture. And I planned for a demo, but due to some constraints I couldn't make today, and we can very well discuss about question and answers as well. Yeah. So this is one of the definition which I didn't frame. I just tried to put it in a different way from learning from different blocks, which very seniors in our tech stack have defined it. So here's how the definition goes. Micro front-end architecture is a design approach in which a front-end app is decomposed into individual semi-independent micro apps working loosely together. So it's the same thing that we might have heard or we might have learned when we are working on implementing an API or a service into a microservice. So it's the same definition that they have applied for the micro front ends.
Madhav, like sorry to disturb. Like I'm
Please.
able to see only the first slide.
Uh,
Is it same for all or just only to me?
Currently, I am in the definition slide. Tim, help me if anyone.
Look, I can see only the main slide, like first slide alone. I don't
Yeah,
see
sure.
the
Mhm.
rest.
Even I can also see the first slide.
Oh, okay.
I think
Uh,
the presenter window has not been shared.
oh, one second. Let
Hmm,
me share
sure.
it again. Is it fine now? Are you looking at the agenda screen?
Like we are able to see agenda now. Yeah,
Okay.
well and good.
Okay, so let me quickly reiterate around the agenda. So this is what I was explaining about the agenda, the definition of about the micro frontends, issues and concerns that made the current tech stack to move towards the micro frontends, and the difference between the mono to micro frontends, and the benefits that we would get once we move to a micro front-end architecture. And then I planned for a demo, but sorry, really, due to some constraints, I could not plan for a demo now. And then followed by question and answers. Yes, and here's this is how the definition starts about the micro front-end. So basically, this definition has only two parts. The micro front-end architecture is a design approach in which a front-end app is decomposed into individual semi-independent micro apps working loosely together. So this definition is nothing new to the current era of the developers, because it is very similar to the microservices which we are daily following or daily using or daily consuming in our projects. So the only change here is the word front end, and which says working loosely together. Basically, when we say micro front end, the main criteria to break a particular app into micro front end apps is every micro front end app should be independent of having its own state. So in current era, whatever the JavaScript framework which we are taking, everything should is mainly we would be looking at what kind of state capability it has, whether it has its own state capability, or do we need to use any other library to maintain its state. So this kind of thinking we would be doing, and that is how the main criteria here is every microfinance app should maintain its own state, and that's how they would be loosely coupled together. The definition ends with working loosely together. And then the micro front end concept is vaguely inspired by and named after microservices, which I was the first definition which I read about the micro front ends. And then let's discuss about the issues or concerns about what's the reason of coming from a monolithic or the legacy way of constructing a website to a newly or a, a regularly used kind of approach like the micro front end approach. If you take an example of constructing a website in the current era, what we'll be doing is like we'll have only one single code base, and from this single code base only we'll take every developer will pull a branch from the actual code base, and they will be keep doing changes upon that. They will implement new features, and they will finally merge everything into one single code base. And this single code base we will push it for the a CI/CD pipeline, or we will do a manual deployment. So when we take a single code base and do all these things, most of the business functionality, rather than putting it in the Java side, we are trying to put it in most of the functionality. We are trying to place it in the front end. I mean the client side only. So when our architecture insists us to keep most of the logic or the business functionality in the client side, I mean in the front end itself, then it will then the size of the app would drastically increase, and the requirements are the kind of functionalities or the kind of components that we are designing in the current era should be not only for the desktop, it should accommodate both responsiveness like the mobile, tablet, and then the desktop. So these three devices should be capable of using this component or the functionality. So when we consider all these three things in this current era, the single code base would keep drastically increasing. And then when we take a single code base, it's always an easy, quick setup when we say it is single, so that is fine. And then there would be not much version management. I mean, even though we use a version management, but when the team of developers is being increased more than 5 or more than 10, the version management would always be a problematic, like which code base they need to use for issues and which code base they need to use for feature management. So this kind of version management is also a question. And then coming to the CI/CD pipeline, which is always a must priority for the current clients, because they have all the security related checks, the code vulnerability checks. So these kind of different continuous integration or continuous delivery pipeline related things should be done. But when we take a single code base, and if we are doing a very small change, and we are pushing this whole code base into every part of the CI/CD pipeline, that would take a lot of time. So let's take a simple scenario like we have the whole app built of, I mean 80% of the app was built, and if we're trying to add a very small component or a very small design change, which doesn't require this kind of all CI/CD pipeline related things, everything, but if the existing architecture or if the existing setup, it has to be done. I mean, the whole code has to undergo all these pipelines, all the CI/CD pipelines. But whereas if we are trying to split the whole app into different modules, or I mean, the different micro front-end apps, and whatever the app that goes under a change that requires a new change or new feature to be added, only that new app can only be expected to be sent to these CI/CD pipelines. And then the concerns. So let's take like we have an Angular JS app, and we have worked very hard in building a lot of different components, and it took like 2 to 3 years completing the whole a website with the Angular JS framework only. And with the current tech stack, we were expected to use some new component, which could not be made with the Angular JS. But even though we were expected to configure with the Angular JS project, which kind of some technical challenges we will be facing. But in that place, if we are splitting, or if we are planning that app in a micro front end kind of behavior, or in that paradigm, definitely we can achieve that kind of task. of using a new component which could not be fitted with the existing AngularJS app that can be added to the this AngularJS app with the micro front-end behavior. And then we can try new stacks which are coming in the current world. So every week or every month we will be hearing about different JS frameworks, uh, like different versions of the existing frameworks as well. So even we can try those new things also with the existing frameworks. So let me take one example. Like we have started an Angular app for a project, and we are done with the basic login form, sign up form, everything with some version Angular 6, let's say. And with the current era, I mean, with the current state, the version of the Angular we were expected to use is Angular 10 or Angular 11. uh, Client expects us to use the latest technologies of today's date, but if we were asked to do that one, we cannot go back and update that Angular 6 app, because there would be a lot of rework needs to be done. So, I mean, if it is, we do have the Angular update features from Angular 6 to Angular 10, we can do very well, but it needs a retesting of all those things. Updating is different from testing. So we would be needing of more time for testing it, like to make confirm that all the changes that were migrated from Angular 6 to 10 within our code base were working pretty fine with the expected functionalities. So in order to reduce that set of time, if we plan to build our app with the micro front-end architecture, we can very well have that login form or sign up form for the Angular 6. And when the user is navigating to a new page, we can very well use this micro front-end app architecture and load the latest design or the latest page which business is expecting to start today with the Angular 10 or Angular 11. So this kind of communication we can establish between these two different pages with two different versions. Even though like even it's not only expected to be built with Angular, even you can go with React as well. You can connect it to an Angular screen, an Angular page with the React page, or you can connect an Angular page to a Vue.js page. So it's not constrained that in a project, one Angular app can only be connected to the another Angular app. It's not like that. We can connect it to a React app or a Vue app. So that's how we would be encouraged to use trying a new stack. And then with existing architecture, one of the other problem we used to face is the development time is very long, and for every development of a feature or issue, the build time would also be very long based upon the current code base, everything. And then the deployment times would be as more as it's possible, because the number of issues that we fix, the number of times we need to deploy it for the testing for both different phases of testing cycles, we need to move it. So let's break these concerns, like what is this long development? Okay. Previously, I was citing an example. When we work with AngularJS, we have built an app for 3 years. So when we say we have built an app for 3 years, why it is taking it 3 years? So it's like when we when the number of developers are based upon the project strength, when we map this kind of chart, that's how when we built the project, it took 3 years. But and that too, we have developed the project with the legacy kind of approach, that the monolithic. But when we see it through the perspective of a micro front ends, it would be very easy. Like we can ask the client, like what are the set of requirements they need, what is from and what is sorry, what is the from and to, like what is starting point, what is the end point, what are the different functionalities they need. So with this one, we can very well split our whole team into different projects, and every team would be responsible for their own input and output from their pages. So let me take an example. Like we have built a sign up form and a login form. So usually what we will be doing is, like, first we will prepare the sign up form, and then we'll get onto the login form. Uh, and then will go section by section. But when we think in the perspective of micro front ends, we can very well kickstart these two projects. Like the login form can be started with its respective security and everything, because this login have a different service provided by the Node.js or the Java API, and the sign up form also will have its different service provided by these microservices. So when we have a different services for them, we can have a different projects for them, and we can very well establish a link between these two projects within a main project. So that's how the development time can be reduced very easily, so it wouldn't have a long development time. And when it comes to build, so every team would be responsible for their own build. So let's say like there was a change in the sign up form only, so only the team which is working, or the person who is working on the sign up form, he only expected to spend time on it, and they will fix that, and they will enhance the feature, and they will give it us. In the meantime, the other teams, they can concentrate on other business logics which they were expected to do. So that's how the build time for that one would be very less, because only the sign up form is only expected to do. When we subtract the whole project into different sections, and only the sign up form project only was expected to build, means the sign up form project will have very very less, probably it will be in KBs only. So for building a KB related code, it will be very very less, the time of building it very less, so it will be done. And then the deployment times, uh, these deployment times would be very less. So the reason of deployment times would be less is only that particular team who is responsible for fixing that issue or implementing a new feature, they would only uh, deploy it. So let's say there are issues with login form, or a checkout form, or a sign up form, or a logout form, or different things. So if we have all these things in a single code base, for every issue fixing, there would be some person responsible to deploy, club all this code and deploy it, and then make sure that it has reached to the respective testing team for them, and ping them to test it. But when we segregate them into different sections, different projects, that particular person who is working on the project only will be responsible, and they can only move it, and the main app which is already pointing to that section will get reloaded automatically. And I'm sure that a couple of times which I have used while describing these issues or concerns are kind of, I have clubbed with both monolithic and micro frontends. Sorry for that confusion, because I think we all are already aware of what the current tech stack is, and this micro frontends is very much similar to the microservices. I thought like if I try to describe it with both these terminologies, that would be easy for you to grasp like what were these issues and what were these concerns. And let's see the differences between these mono to micro frontends component architecture. So here in the first diagram, which I was actually explaining this monolithic way. So the monolithic way, when I say, is like it might be having only one service and only one front end app, but it has only one front end app, and it can have more than one service. So when we say more than one service, it can be a microservices app. So from one service to splitting that one service to microservices, the service layer only got changed, but the front end app was never changed. It has only one particular code base, one particular deployment cycle, one particular CI/CD pipeline, everything. Only the service layers were changed. So this is what the monolithic way which I was actually using the term. So if there was any business functionality change, that particular API team will work, they'll fix it, or they will enhance it, and they will push it. So parallelly, if there is any change with this one API, the front end team needs to work, and they have to fix it, and they have to take it until the deployment, until the prod. Similarly, if there is any change in service too, this particular team would only work, and this front end team have to rework again, and they have to take it up to the deployment time. So here when I say the front end team, so whatever the number of team it is, they all have to work, and they all have to see like none of their code is getting disturbed because of a change within the service 2 or within the service 3 or within whatever the service may be. And this kind of a lot of rework and redundant work has to be made by every developer within the front end team, and then they have to confirm and they have to send it for testing. But this is one kind of real-time problem which we are facing currently. But when we compare this same monolithic way and the issue of a new feature or a new issue fixing in a service 1 or a service 2 or a service 3, when we correlate this thing with the latest paradigm of called micro frontends, that would be very easy. Like this redundant work or redundant testing is all can be avoided. So let's apply the same example to the micro front-end architecture, whatever we have here. So let's say like, so this is the diagram which actually represents a very short snippet of micro front-end architecture. I don't thought to add all the other um, the tags to this diagram, which would add more headache. So I thought like a very simple diagram would help you to understand what exactly this micro front ends. So I thought like correlating with the services directly would help every one of us to understand what actually the micro front ends that globally everybody was using it. So currently, most of the apps that were already built with micro frontends, they were all tied to every single service. There was every one single front end app. So for service 2, front end app 2, service 3, front end app 3. So this is how a very plain micro front end app can be constructed and also be deployed without any problem. It will work very pretty nice actually. So when we try to, so let's try to apply the same problem which we faced in monolithic into the micro frontends, and let's see like what would be the like the steps to fix it. So let's say like if there is a change in service 1, so the only expectation here is when we say there is a change or a feature was added into the service 1 or business functionality was added into service 1. So when we say this new thing or this new thing came into picture of service 1 is, it would have a clear architectural decision at the high level, like which service has to handle that thing. So when that kind of design thinking or that kind of architectural thinking was made at the high level, that keeping in view that we are working in the micro front ends, only that particular service would be planned for the change, and it should, and also it would be planned in such a way like, and it has to be planned in such a way like it shouldn't affect any other front end app. So that's how they would be losing, that's how they would satisfy the definition they are loosely coupled. So when there is a change in service 1, the front end app 1 only will have some changes, and this front end app one only will have the team whoever are working on this front end app only will app one will only do those changes, and they will send it for testing. If the app is very large, if the whole app is very large, the front end app one will might have its own testing team, and they will test it only. They will only test it, and the other two teams are not required to concentrate on this change because they are following the definition of loosely coupled. And this front end app one will only undergo all the different testing strategies and then CI/CD pipeline everything, and then finally push it to the prod. And similarly, if there a change in service to only this two front end app two will only follow all these practices, and the other two teams are not expected to work on this. So that is how the front end that is how the micro front ends will help developers as well in concentrating more on the business logic or what the customer is expecting from us, rather than concentrating, rather than thinking about the issue of service one would the issue in service one or a feature enhancement in service one would will bring some impact on my code. So this kind of thinking is not at all required. And, and when we can very well correlate these front-end app 1 app 2 app 3 with the current tech stack, like the Dockers, Kubernetes, everything. If the app is very huge and we were expecting the app to run very fast, if we are deploying only the front end app, this one project into a Docker or a Kubernetes, yes, it will very well work pretty fast. But as the app is expected to be adding new pages or new components or new features, the size of the app would keep increasing and the performance might get loosed. But we can resolve that issue by applying these micro frontends to this one. So let's apply this micro frontends to this front end app, and that's how we'll have this front end app 1, 2, 3. And for every front end app, we can have its own container. And when we now try to observe in like having one container with the whole app and having different containers for different apps, thus there would be a certain amount of sorry, performance would increase having a single container to having three containers. And similarly, it would also resemble for the service 1, service 2, service 3 as well, having different containers. And this is how we can very well ensure that our app works pretty fast. And when we actually tag this Docker, I mean, the containerize, I mean, we try to containerize our apps, definitely the performance would be pretty fast. And availability of the apps is damn sure with this containerization. That's the reason I mean, availability is the main criteria. That's why we are moving towards the containerization. And this is all something about the differences between monolithic and micro frontends. And these are the benefits which we were discussing when we around the previous slides, like the reusable code. So whatever the framework, if we take now, like AngularJS, React, Vue, or whatever the JS framework, we were all encouraged to use a reusable components. So when we say reusable components means the web components, we do got a couple of frameworks to you build the web components, and these web components we can very well reuse it in every framework, irrespective of like irrespective of what the other framework is. So let's say like I have prepared a component with the help of web components API, and that web component in any other JS framework like React, Vue, or anything. So with that, when we try to correlate that one to the micro frontends, we can very all these components in a on whatever the component that business requires. We can have all these, and we can have a utility module. So this utility module, we can point it to every micro front-end app, and we can try to use that particular component only. And even we can apply a lazy loading feature for that for every component. And whenever it is required, that particular component will load into the every micro front-end app. And this all this lazy loading or the linking to the existing micro front-end app would be completely relied on the framework that we were using. So framework here in the sense for a micro front-end app 1, I was using Angular, and micro front-end app I was using the React. Within the existing framework, the React. So how are we trying to utilize the lazy feature? So that kind of reusableness we can bring it here. And agility, which is the burning word now. Yes. So when we see our code in kind of our application in the kind of agility manner. And like we were you building the whole app in the micro frontends, right? So when we building the micro frontends, every the whole project would be split into different projects, and the requirements can be clearly categorized, like which micro front end team can use which, how to build which requirement. And that so every team would be responsible, and they have their own work, like what was the input, what would be the output, how I mean their thinking would change in completely, like what have to be delivered rather than what has to be designed, or what have I mean how to do or something. And then reduce risk. So when we say reduce risk, having the whole project in a single app, and if the app crashes at any stage, we have to make sure that we have to build it again, the whole app, and then we have to push it again to fix it, or whatever the fixing mechanism that we plan when the app crashes. But if we are building the whole app in the micro front end kind of approach, this risk would be reduced. Like anyone, if there were six micro front ends are playing to build our app, so any one of the micro front end might get crashed. And if we are tagging them with the containerization, definitely that risk can be minimized. Or, or if there were no containerization applied also, if one particular front end app is down, it only that particular section will only going down, the other sections wouldn't be going down. So the user wouldn't get an abrupt message like, oh, the app is not working. No, only that particular section might not work, and which we can fix it very early, because we have very very less code, and we can be known like what was the issue, and we can fix it easily early, and then we can push it. And easier testing, which I was saying. So every front end app would have its own business functionalities, and the testing team can easily know about what functionalities the front end app is going to deliver. And if there is any change, they can draft the test cases easily, and the testing would be very easy. And which is the last one is the self content, which I was saying. So every app will have its own, if we tag its own containerization, so every app will have its own resources that they need. And even we can add like the functionalities only for that app. And when we say self-content, they are loosely coupled, so that's so that these two terms we can closely match. So these are some a very very minimal benefits that can be acquired. I mean that I have listed here, that we could very well receive from the microfinance architecture, and there are a lot more benefits that can be get. And before wrapping up the session, which I understood from micro frontend app, which I would like to share with you all, is micro frontend architecture is not something new. It's all with the resources whatever we have. We are trying to build an app in a different way, but when we are planning to if we are planning to apply this micro frontend app, it needs a lot of architectural thinking, like what is the need of applying micro front-end app with the existing application, what benefits we would get it, and what kind of logic we are actually building. Does this logic need the micro front-end architecture or not? Because sometimes the situation might be like, instead of I mean, we might think like we might complete the app in a lesser time if we are applying micro front-ends, but the situation might turn in a different way because of lack of proper architectural decision at the initial time. That's the one thing that I faced. I thought like it might help you all also. And I'm sorry, as I told, due to some technical constraints, I could not bring up the demo actually. Sorry for that. And any questions and answers that I can help you with, or you can very well give me a chat.
People, if you have any questions, kindly raise your hand. Otherwise, like you can use the Q&A box that we have here. Like Madhav, like I have one simple question, like basic question, like how do you handle the common components? Let us say like we are having three different micro frontends. Suppose
Okay.
they are using the same component which are rendering. Like how we manage it while deployment, and same with the repository. How do we share the code?
Okay. Even it was also one of my question when I was started working on the micro frontends. So one way that helped me to understand or think to solve that issue is I thought like instead of thinking about a different projects, I thought like these three projects are in the three different folders. Let's say like folder one, folder two, folder three, and these utilities, whatever that would be used across all the different apps, I put it in a separate folder called utilities folder. And with the existing latest frameworks, we could very well expose a module from that utilities folder, like utilities module, and I was importing that utilities module wherever it is required. And also what I was trying to do is like to improve the performance, we could apply the lazy loading of that module, and for every component also we can apply this lazy loading. That's how even we can achieve a better performance also.
Okay.
I think this might help you to correlate how
Yeah.
we can achieve it.
Thank you.
Thank you for that question. Actually,
Welcome.
that's no, no. I seriously like it is one thing that took me a couple of days to understand actually,
Hmm.
because a same component or a same piece of code is not maintaining in every project is not a good practice, and again it would increase size of the app as well. That's the
Okay.
reason we have these utility
Yeah.
modules.
Okay, let's wait for a couple of minutes for any other questions.
Sure.
Yeah. So, yeah, in the meanwhile, we did really appreciate you to fill the feedback form. So, I'll be sending out the feedback link. So, it would be nice for you all to answer it for the first session. Okay, I believe there is no questions coming up. So, thank you, Madhav, for your wonderful talk. I think you put forward your points with examples. So, that's very informative. Thank you so much.
Thank you, man. Thank you,
Thank
Shivin.
you.
And I think there's one question from Karthik.
Oh, and
Hi, one.
use different frameworks for different micro frontends. The library would still be separate for him every frontend. Right? Yeah, I'm. Hey, Karthik. Yes, the frameworks would be different for every front-end app, and also with this, we can I can correlate one more point as well. Um, when we try planning to build the app in micro frontends, it's not expected to have all the developers knowing only one particular framework to build the whole app. We can encourage different persons who know different frameworks, and we can all gather at one place and we can build an app with the help of this micro frontend architecture. Hope I could answer your question. Thank you, Gandhi.
Shakti, do we have any questions from YouTube?
No questions from YouTube so far.
Okay. So,
I think like they're good to close, I believe.
okay.
Hmm.
So, yeah. Thank you, Madhu, once again for the wonderful talk. Thank you.
Thank you, Monica. Thanks for giving me this chance. Thank you so much. Thank you, Shakti.
Thank you. So, before we move on to the next session, so let's take a quick break for 5 minutes. Say we can join by 6:58.